What's up, everybody? Welcome to another video of Math Chat with Mr. Richardson. I'm going to be your host for about the next 10 minutes where we discuss how do we simplify radical expressions. Thank you to all my subscribers on YouTube, all my students on Edpuzzle. Let's get it. First thing we want to go over in this section of the video is some basic vocabulary that we're going to be using. When we're talking about square root, cube roots, any of those type of roots, the first thing we have to understand is that this piece under the radical sign here, just the x in this example, is called the radicand as it sits underneath this piece here, which is called the radical symbol. This piece here, this little 3, we won't be talking about much in this video, but this is called the index, and it changes what type of root you have. So the radicand, again, the quantity underneath the radical sign. The index signifies what type of root, and of course 3 would be a cube root, 2 would be a square root, and today when we don't write any root there, meaning it's the absence of an index, that means it's a square root. The next type of key vocabulary we're going to have to know is a perfect square. A perfect square is a number that you get by squaring an integer or a whole number. For instance, let's compile a list of perfect squares. So let's take these numbers here, 1 through 12. We'll start with these. I think that should be enough. If we square these numbers, we will obtain the list of perfect squares. For instance, 1 squared is 1, 2 squared, 4, 3 squared, 9. 4 squared, 16, and we could complete this list and we would have the first 12 perfect squares. So all of these numbers in blue are our perfect squares, and we're going to be needing these to do a lot of the math that we're going to do today. So in this next section of the video, I'm going to explain how to simplify radical expressions, and that's really going to be the main idea behind this video. So here's how you simplify a radical expression. First part is you need to find the largest perfect square that divides the radicand, or the piece underneath the radical sign, evenly. After you've done that, you want to rewrite the radicand as a product of a factor pair that includes the perfect square found in step 1. Now that sounds really difficult, but it's not really, and you'll see that. And the last part is just to simplify the perfect square. So here's 3 examples I'll do with you before we practice. Here I want to simplify the square root of 50. The first idea is to find the largest perfect square that divides 50. Well, maybe we'll go back to our list. That may help you. 50 appears probably around here. It's a little bit larger than 49. So I want to find the largest perfect square that divides it evenly, so I'll just be looking this way. Well, is 50 divisible by 49? No. Is it divisible by 36? No. Is 50 divisible by 25? Yes. So I have found, in this case, the largest perfect square that divides 50. It's 25. So here in step 2, I want to rewrite this radicand as the product of 25 and what number? Well, 25 times what is 50? It's 25 times 2. In the last step, I want to simplify. All of these perfect squares simplify, and the square root of 25, you probably should know, is 5. So this is just 5 radical 2. These 2 expressions here are equivalent, but this is the simplest form, or the one that is in simplest radical form. Let's try example number 2. I want to find the largest perfect square that goes into 300. So I can go back to my list. 300 is like way over here. It's like off the scale. So I can check this way. Does 144 divide it evenly? No. How about 121? No. How about 100? Does that go into 300 evenly? Yes, 100 does. So 100 is the largest perfect square to go into 300. Step 2, rewrite 300 as a product that includes 100. 100 times what is 300? 100 times 3. So I can rewrite it as this product. And then in the last step, I just simplify the perfect square. The square root of 100, if you didn't know, you can see the square root of 100 is 10. Let's try one more. In the last part, I want to simplify the square root of 125. I need to find the largest perfect square that divides it evenly. 125 sits here between 121 and 144. Well, 121 doesn't go into 125. Either does 100, not 81, not 64, not 49, not 36, but 25 does work. 25 times what number is 125? 5. And in the last part, just simplify the perfect square. The square root of 25 is 5. It looks like this. Now here's a mistake that you're going to make when you first start to do this. One mistake that students make is they start to just write all these radical signs because there's radical signs everywhere, and they're going to start and put radical signs here, meaning they write radical 5, radical 5. That's a mistake there. One thing that you want to make sure is when you simplify the perfect square, you get rid of that radical sign. So let's give you a chance to practice. In this next part of the video, I'm going to give you 3 problems to practice on simplifying radicals. Why don't you try to simplify this one right here? Step 1 is to find the largest perfect square that goes into radical 20. The largest perfect square to go into radical 20 is 4. Then I have to think 4 times what number? Well, it's 4 times 5. Now the perfect square should always be written in front. I'm going to simplify the square root of 4 is just 2. Let's try another one. See if you can simplify this radical. Well, the first step is to find the largest perfect square that goes into 45. The only perfect squares smaller than 45 are 36, but 36 does not go into 45. I could try 25. That doesn't work. I could try 16. That doesn't work. And finally, I get to 9, which does work. Well, 9 times what number is 45? Well, it's 9 times 5. Now just simplify the perfect square. The square root of 9 is just 3. Let's try one more of these. See if you can simplify this. Well, this one's a little bit different. What's going on here is you have this coefficient of 2, and that coefficient of 2 is just in a product with the square root of 50. So what I'm going to do is I'm going to simplify the square root of 50, bringing the 2 along the way, and at the end I will be able to take the product of 2 and whatever numbers come out of that perfect square. So let's do that. First thing I want to do is find the largest perfect square that goes into 50. It's 25. 25 times what number is 50? It's 25 times 2. Notice that this 2 didn't go anywhere and that I broke down the square root of 50. Now I want to simplify the square root of 25, or simplify our perfect square. The square root of 25 will be 5. Now finally that I have 2 constants here, I can multiply these. The product of 2 times 5 is just 10, and my final answer is 10 radical 2. In this next section of the video, what we're going to do is I want to give you one more property, which is what happens when you take the product of radicals or when you multiply them. Essentially, when you take the product of radicals, you just multiply the radicands, or what's underneath the radical sign. So for instance, if you have radical A times radical B, you can multiply those pieces underneath the radical sign, or you can multiply those radicands and put the product underneath. Another property that you should know is if there's coefficients in front. This example shows that. You could multiply the coefficients in front, for instance m and n, and here you could also multiply what's underneath. Let's look at example number 7. If you look at example number 7, I can't break down 3 and I cannot break down really 6. There's no perfect squares that go into them, but I could take their product, and radical 3 times radical 6 would just give us radical 18. When I've gotten to this point here, now I might be able to simplify this. I'll look for the largest perfect square that goes into 18. The largest perfect square that goes into 18 is 9, so I could write 18 as the product of 9 and 2. Now I just want to simplify the perfect square. The perfect square is 9. This becomes 3 radical 2. Let's take a look at example number 8. In example number 8, you have something a little different going on. You have a coefficient of each radical term, and you also have the radicand. The idea is that we want to multiply the coefficients and multiply the radicands to take this product. So I can multiply 2 times 3 and I'll get 6, and 5 times 15 will be 45. Oops, sorry, 5 times 15 is 75. Now I want to find the largest perfect square that goes into 75. The largest perfect square that goes into 75 is 25, so I can write this as 25 times 3. Notice the 6 didn't go anywhere. It's going to wait until I have another constant to multiply it by. Simplify our perfect square of 25 becomes 5, and finally I can multiply 6 times 5 and get 30. Let's see if you can practice 3 of these on your own. See if you can express this product in simplest radical form. So here what you have to do is take the product. You can multiply the radicands. 8 times 2 is 16. And what happened here is kind of sweet. 16 is a perfect square, so the square root of 16 just simplifies to 4. Very nice. Let's try another one. See if you can solve number 10. So to solve this, multiply the two radicands. 3 times 21 is 63. Now look for the largest perfect square that goes into 63. The largest perfect square that goes into 63 is 9. 9 times 7. Finally, just simplify the perfect square. The square root of 9 is just 3. The solution to this one is 3 radical 7. Let's try one more before we get you out of here. See if you can express this product in simplest radical form. Well, here what I want to do is I need to multiply the constants in front and also the radicands. 5 times 2 is 10. 6 times 12 is 72. Now 72 has a few perfect squares that go into it. I believe 9 goes into 72. I also believe 4 goes into 72. However, none of those are the largest perfect square. And if you ended up simplifying it with 9 or you ended up simplifying it with 4, you probably didn't get the answer in simplest radical form, and that kind of shows the importance of picking the largest perfect square. Well, the largest perfect square to go into 72 is 36, so I can bring down my 10 and write 36 times 2. Now simplify my perfect square. The square root of 36 is 6. And finally, 10 times 6 is 60. This becomes 60 radical 2. I hope you learned a little bit in this video about simplifying radicals, but of course this is just the start. I encourage you to go and practice more of this work on your own and see if you can become somewhat of an expert in simplifying radicals. Thanks so much for tuning in. Until next time.